we need to remember this. Then we have potential difference, that is V. V is equal to W by Q, that is work done by quantity of charge moved, and we represent this potential difference as V, and it is volt, that is the SI unit of this potential difference. 1 volt equals to 1 joule per coulomb. And we have this I equals to Q by T. This I equals to Q by T is current equals to Q by T, that is Q is the coulomb charge flowed, and this is the time, that how much time the charge flowed. Then we have the most important thing we have, that is our Ohm's law, which is very much important. So Ohm's law tells us that current is directly proportional to volt, that at a constant temperature, and volt is directly proportional to I, that is the vice versa. So we have three major formulas for the Coulomb Ohm's law, that is V equals to IR, R equals to V by I, and I equals to V by R. And here R is a constant. R is a constant means R will not change. Now then we have resistivity and resistance. So resistivity is represented by rho, that is a Greek letter, and resistance is represented by R. So resistance equals to rho L by A. Now here some people confuse in the A, that what is this A? Is this ampere or what? So A is basically area of cross section of conductor. Now what is this area of cross section of a conductor? So imagine it like that, that if I cut a copper wire perpendicularly and excluding the insulation, the surface area of that copper wire through which the electricity will pass will be called the cross section of conductor. Okay, so basically it is the surface area of the conductor. Then we have, so from this formula we can found the resistivity, that is Ra by L, that is resistance multiplied by area of cross section by length of wire. L is the length of wire. Now in a specific condition, that is if area is 1 and length is 1, then we will get a very interesting thing, that is the resistance will be its resistivity, and vice versa, resistivity will be its resistance. Moving to our next thing is factors affecting the resistance of a conductor. So what factors affect the resistance of a conductor? So there are four main factors that affects the resistance of a conductor. That first is R is directly proportional to length. That means the length, as the length increases, resistance also increases. As the length decreases, resistance also decreases. R is directly proportional to, inversely proportional to the area of cross section of conductor. Means if the area of cross section decreases, the resistance will increase. That means